So your formula for weighted average, we're basically going to have a bunch of coordinates and weights, and we're finding the weighted average between 2 points. So basically, if I am a number line and I have 2 points on my line, here's the point, here's the point. If I say this one has a weight of 1 and this one has a weight of 5, okay, because this one's heavier, the weighted average is going to fall between the points, and it's kind of like a scale. The heavier side, that point is going to pull towards the heavier side. Okay, so you should always have a weight that's heavier, basically, and then it's going to pull towards that heavier weight. If the weights were the same, let's say I had 2 coordinates and the weights were exactly the same. Let's say this one was a weight of 2 and this one was a weight of 2. Where would the coordinate point fall? If the weights were exactly the same. Right in the middle. Okay, and then it would be the midpoint. So that's really never going to happen because then it would just be the midpoint of the line. So we are going to find the coordinates of P that represent the weighted average for each set of points given the number line with the provided conditions. Okay, point B has a weight of dose. So right underneath point B, I'm going to say that this one has a weight. I'm just going to call this point 1. I'm going to say that this has a weight of 2 because that's what they tell me. They also say point A has a weight of 3. So I'm going to call this weight 2 because it's the second weight that's given, and it doesn't matter which one's coordinate point 1 and which one's coordinate point 2, which one's weight 1, weight 2. As long as you put it with its proper variable, then that's all that matters. So this one has a weight of 3. The next thing that you need is x1 and x2, which is the coordinate of where it's at, basically the location on the graph. So if I look at point B, I'm going to call this x1 because the little 1 should be with each other. Where is B at on my graph? -7. Where is A at on my graph? 2. And then I just have to plug these values into the formula. And you can either solve using PEMDAS, orders of operations, or you can plug it into Desmos, which is what you should do because it makes your life easier. So the formula is the weight multiplied by the location. So weight 1 is how much? 2. And I'm multiplying by its location. So where is that at on the graph? So what is x1? Where's x1? -7. And then over here, we have the second weight. How much is the second weight? 3. And I'm multiplying by the second location. Where's the second location? 2. And then I just add the weights together. So weight 1 is -7. What? Weight 1 is not -7. Weight 1 is 2. And weight 2 is 3. So the weight can never be negative. That would not make sense. And then we can just plug this whole thing into Desmos. If you know math, you can solve it using math. But most of you don't know math. So we're just going to plug it into Desmos. Okay. What's up? So if you go to Canvas, go to my class. You're going to need the fraction bar first. So first my little. So you need the fraction bar first, and then you're going to literally type all this mumbo jumbo in there. Did you find it? Is that right? Yeah. -1.6. And that's it. That was easy. So if you type it all in, the hardest part is making sure it's a fraction. We're going to plot this on our graph. So the answer falls between -1 and -2. So if I put this on my graph, -1 to -2, it's closer technically to -1 or -2, but it doesn't really matter. This is my point. That's my answer. And if you think about it, this makes sense. Because A has a weight of 3 and B has a weight of 2, A is heavier, so my point is closer to A than it is to B. If your weight or if your weighted average ever falls outside of your coordinates, that is wrong. Something happened. The weighted average should always fall between the 2 points. Not too bad. Let's do number 2. Number 2 is the same thing. The wording is just a little bit different. What's up? Because it's like where it's at on the graph. So B is right above -7. When I made this on a Word document, it's supposed to have a dot there, but it's like right above it. The dot's like disappeared whenever I printed it. I don't know why. So like where the point is at, normally there's a point here. Like this should really be a point, and this should really be a point. So those are like your X1 and X2, like your locations. Does that make sense? So it's like just hovering above it instead. So 2 says point C and D have. Yes. Yes. Oh, hey. Okay. I like okay, that's okay. Yeah. You too. Okay, bye. Okay. Anyways, so for this, it says point C and point D have weights 5 and 2 respectively. Find the average weight of P. So this is the wording that they use on the midterm, and this is the wording that they use on the cycle assessments as well, just so you know. So because they say point C first, it does not say point C has this weight. Because it says respectively, it means in the order in which it's given. So C has a weight of 5 because it's the first one it talks about. So I'm going to put weight 1 over here. I'm just going to call this one weight 1 now because that's the first one I'm talking about. Like I said, it doesn't matter which one's technically weight 1, X1. Because it's the first thing they're talking about, I'm just going to put weight 1 over here. This is 5. And then because D is the second one that they're talking about, D is going to have a weight of 2. So it kind of goes in the order in which they're talking about. After I have my weights listed, then I find my locations. So where is C actually at on my graph? 8. Where is D actually at on my graph? 1. And then I plug it into my formula. You're doing weight 1 times location plus weight 2 times location. You're dividing by the weights added together. So let's plug it into our formula. So here's our formula at the top. So weight 1 is 2. No, weight 1's not 2. Jesus. What's weight 1? 5. What's X1? No. 8. So you're doing 5 times 8, and then you're doing weight times location, 2 times what? In the denominator, you're adding the weights together. So the 2 weights are 2 and 5. So take a second, you're going to plug that in. So plug it in to Desmos. This one you should get a whole number. Did you get a whole number on that? It's not 30. Yeah. Oh.
We put 5 more into it.
Oh, okay. So if you plug this into Desmo, you usually get 6. How do we feel? That's not too bad, right? Get off your phone, Leslie. Try number 3. Easy peasy. Easy.
So if you want to call, as long as like the location matches with the weight of mine, so C has a weight of 5. So mine is which I'm using C has a weight of 2, and it's at 1/3. Okay. So C has how much of the weight? Yeah. So this one is first, so what's the weight of that? Yeah, so that was weight of 2 and its location is that. For 2, like, is equal together. Hold on. Mommy, for your time.
Yeah, that's good. So C has a weight of 2. So I'm gonna call that one weight 1. It technically doesn't matter if you call this one the little 2s though. It doesn't matter if you put 2s next to these. This is -8. This one over here will have a weight of 4. And its location is at 1. As long as 8 and -2, or I mean, sorry, 2 and -8 are multiplying together and 4 and 1 are being multiplied together, you can reverse it in the formula. It doesn't matter. As long as these 2 are together and these 2 are together. So weight 1 is 2. I'm multiplying by -8. I'm adding weight 2, which is 4. You're multiplying by 1. So these get multiplied. These get multiplied. They're being added together. And then all you're doing is dividing by the weights added together. So weight 1 is 2 and you're adding 4. So when you put that into the calculator, what do you get? -2. If you plot that on your picture, -2 is right here. And -2 is closer to E because E has the heavier weight. How do we feel? This isn't bad, right? This is easy. We're gonna make it a little bit harder, and then we'll do it on a 4-quadrant plane, and then you guys can just practice. So 4 says determine the average weight. Yes, bring your phone. Determine the average weight of P if X is 3 times as much as Y. So it does not say the weight is this and the weight is this. It doesn't say the weights are respectively this and this. It says it's 3 times as much as the other one. What? So let's start with just organizing our thing. We know this one's we'll just call this weight 1. We'll call this one weight 2. We'll figure that out in a minute. This is gonna be X1 and this is gonna be X2 because like we need those just to match together. So where's X at on my graph at what number? 2. Where's Y at on my graph? 6. And now I need some weights. I need them to be numbers. I can use any combination of numbers as long as X is 3 times as much as Y. So what combination of numbers could I use? I can use 3 and 9. What else could I use? Anybody else? Is there anything else I could do? Use 3 and 9. I could use 7 and 21. I can use 4 and 12. I can use 2 and 6, 5 and 15. It doesn't matter. As long as it is 3 times as much, then that's all that matters. If point X weighs 3 times as much as Y, which one is heavier? X. X is heavier. So X has to be the bigger number. Most people said 3 and 9 first. So let's use 3 and 9. So X is the heavier number because it weighs more. So that one will have to be 9. What's my other value going to have to be? 3, because it's 3 times 3 times as much. So take a second, plug in your numbers. So whenever they give you these in words, you can use any combination of numbers as long as it qualifies to be 3 times as much. Somebody last class was using. Oh, that's for the next question. I'll tell you the next question, what the numbers they were using after we talk about it. Because they were using some wild numbers. I was like, whatever. They got the same answer. So what do we get? 3. Okay. Number 5. 5 is the same thing. 5 says determine the average weight of P. If point U weighs 1/4 as much as Z. So I need a combination of numbers that represent 1/4 of another number. So U weighs 1/4, so U is lighter, 1/4 as much as Z. 4 and 16. I can use those. What other combination of numbers could I possibly use? 20 and 5. What's another combination of numbers I could use? Let's do one more. 12 and what? 12 and 3. Yeah, 3 and 12. You could do that.
So you got.
You could use 1 and 4. Somebody last class used 25 and 100, which comes out to be the same answer, which works. As long as one is 1/4 of the other one, it doesn't matter. So it says U weighs 1/4 as much as Z. So which one is heavier? Which one is more? No, not you. Z. Z is heavier. So let's pick a combination of numbers. What combination of numbers do we want to use? 1 and 4. Sure. I'm going to say Z is heavier. So Z is going to be weight 2, and that one's going to be my 4. This one's going to be weight 1, which will be 1. Because it's 1/4, so it's 1 and 4. You could use 2 and 8, 3 and 12. Right? 3, yeah. 3 and 12. 4 and 16. Yeah. 5 and 20. As long as it's multiplying by 4, then that's all that matters. So take a second, plug it into your formula. This one, you do get a decimal, so don't freak out when you get a decimal. It's all right. It's okay. Someone's out when they get back. What do you get? Is it positive or negative? Negative 3.2. So plot it on your graph. It's between 3 and 4 somewhere. Don't think too hard. Don't hurt your brains. It's closer to Z because Z is heavier on your number line. If it ever falls off of the number line, it's wrong. It should be between the 2 points because that would not make sense if it was not between them. So now we're going to make it just a tiny bit harder, which this is not hard. And plus you have Desmos, so you're literally not doing any math. You just have to set up the problem. So this is like just the x-axis, right? This is literally just x. Now what we're going to do is we're going to add in a y-axis. So instead of doing it one time, just like when we have midpoint, we add the x's divided by 2, and then we add the y's divided by 2. We just got to do it twice. So we got to do X and we have to do Y, and then we're basically going to squish them together to make a coordinate point. So on the back, we have a coordinate grid. We're going to do number 6. Number 6 says, determine the weighted average of AB. AB is a line on a graph. If it has a weight of 4 and B has a weight of 2. So let's start by finding our coordinate points. So where's A at on my graph? Negative 2, 0. We're gonna call that X1 and Y1 because it's the first point I found. What is the weight for A? 4. And then let's find B. So where's B at on my graph? Good. So that's gonna be X2, Y2. And then what's the weight that goes with that? 2. Okay, so this is the formula technically we're using, which looks a hot mess. Okay, it's literally the same thing twice though. So when you have it on a graph like this, you basically are finding just using the X values. Okay, we're doing weight times X, weights added together. It's literally the only thing that's changing from this one to this one is instead of X's, you're using the Y's. Okay, so we have to do it twice. We find X and then we find Y's. So first we're going to focus on just our X's. So if I want to do the same formula, I'm doing weight 1. I wonder if I can like show you the formula at the top. Yeah, there we go. So there's the formula from the front. We're doing weight 1. So what's my first weight? 4. So weight 1 is 4. How much is X1? Negative 2. And then I'm doing weight 2. How much is weight 2? 2. And then I'm multiplying by X2. What is X2? 3. And then you're multiplying by the weights added together. So weight 1 is 4, and I'm adding 2. So this is just all the X's being used in one equation. So we have X, which is literally X1 and Y1. So somebody plug that into Desmos. You get a decimal, I'm pretty sure. Yeah, you get decimal. 0.3. Is it positive or negative? I think it's negative. Isn't it negative 0.3? Negative 0.3. And it's like 0.3333333. Yeah. So we're just going to say 0.3 repeating. Remember that little line on top means the repeating symbol. So the formula stays exactly the same. The only thing that changes is instead of X's, now we're not dealing with X's, now we're dealing with Y's. So literally it's the same exact formula, but now it's Y1 and Y2. So everything in the formula stays except for this and this are going to change. So I'm doing 4 times something new, 2 times something new, and I'm still dividing by 4 plus 2. The only part that's actually changing is instead of X1 and X2, I'm using Y1 and Y2. So what is my Y1? Y1 is 0. How much is Y2? Negative 5. So this is Y1 and Y2. So all you have to do in your calculator, in your computer, is change those two values. So instead of X's, now we're Y's. How much does that equal? 1.6 repeating. The reason why there's a 7 at the end is because the 6 continues forever into like literally forever. And because it's more than 5, it's saying that last number is 7. So it's just 1.6 repeating. So my coordinate, and it's negative, is negative 0.3 repeating, comma, negative 1.6 repeating, which is like ugly to graph. But if I put that on my graph, it's like here-ish. It's closer to A because A has a heavier weight. The weight was 4. So you have number 7 to do. Number 7 is a decimal. So if you want to put a little star next to number 7 is a decimal. Number 2 down at the bottom is also a decimal. So when you do number 2, don't freak out because number 2 is a decimal. Everything else is whole numbers. It's kind of like a mixed review at the bottom. You're going to take a picture of this and you're going to turn it in on Canvas because it is notes. I don't take your notes papers. So you're going to take a picture of just the back when you're done and you're going to turn it in on Canvas. So if you need to make a little note, you're turning this in on Canvas, just the back. If you take a picture of the front, that's fine too, but like Canvas, back, because we did the whole front together, so I don't really need to see the front. Okay. Let me know if you get stuck. Let me know if you need help. If you get decimals for other than 7 and 2, then like red flag, something happened. Check with a neighbor, check with a friend. When you're done with this, take a picture of it, put it online, and then start on your test review. Believe in you. You can do it. Use Desmos. Easy peasy.